This is 1 upon, it will be equal to 1 in that situation. This function is, here x is less than 1. That means this function is not convergent. This function, because it will be 1 upon, this is convergent here, this is not convergent. This is not convergent. As mu is less than 1, okay, because it is equal to half here, we have taken x is for mu into whatever function is, fx here is this. Okay, so if I divide numerator and denominator by x square, get a square upon x upon 1 plus x square, here it will be x square only. Okay, we have to make the same thing in the numerator. If I divide x square upon x square, this is 1 plus 3, 4, powers are added, so x square upon this will be 1 here. In that situation it is 1, that means you have to compare by mu only. So mu, for that mu is equal to half. Whenever mu is half or less than 1, that means function is not convergent. This is not convergent, or it is divergent, or it is divergent here, or it is divergent. This is known as mu test. Therefore mu test we can do this. Now in the second case, last one question, 12th question, sorry. So in question number 12, what does it? Let us talk about this. Now question number 12. Okay. Now question number 12 says, test the convergence of the integral a to infinity. It is cos square x upon, okay, x square. This is x square into dx. Now again, if I do this here comparison test, which is 1 upon x square, let f2x is equal to cos square x upon x square, okay, and f1x is equal to 1 upon x square. The comparison test here. So modulus of, or absolute value of f2x, let me take, is less or equal to f1x. This is, sorry, f1x. f1x. Here, this means modulus cos square x divided by x square less than or equal to 1 upon x square. But 1 upon x square is convergent. This function will be convergent. Okay. But a to infinity 1 upon x square dx is convergent. Is convergent. From first question, x n is greater than 1, n is equal to 2 here. Whenever n is greater than 1, in that situation the function will be convergent. So this is convergent here. Okay, so this 1 upon x square is convergent. Therefore, now given function a to infinity, this is a to infinity cos square x upon x square dx is also convergent. Is also convergent. Is also convergent. The function is convergent here. Okay, the function is convergent. This is 12th question we have done. Now let me talk about next question, 13th one, and then 14th question. What does 13th question say? Okay guys, so this is, we are talking about convergence of improper integrals of first kind. The first kind of improper integrals, convergence of that we are talking about. This is what we are discussing. 13th question now. Question number 13 says, test the convergence of a to infinity dx upon this. Okay, so this is a to infinity dx upon under root x square minus 1. Now if I take this as, this is 1 upon x square minus 1. So this is less or equal to 1 upon x, where absolute value under root x square minus 1 is less than or equal to 1 upon x. Whenever x is here, square root of x is, x square is x, because of that we take this as this value. This is less than, 1 upon x is not convergent, it's divergent, but let me write here, a to infinity 1 upon x, 1 upon x into dx is divergent, is not convergent, as n is equal to 1 here. Whenever x is power n, and here is 1. For n is equal to 1, it is convergent. It is not convergent. It is divergent here. So it is log of x is infinity. When put the infinite limits, so it will be infinity in that situation. When as n is equal to 1, this is not convergent. Therefore, f1, this was not convergent, so this is also not convergent. Hence, therefore, a to infinity dx upon under root x square minus 1 is not convergent. Is not a convergent integral, improper integral. Is not a convergent improper integral. Okay, so this is convergency and divergency of improper integral. Sorry, let me write here improper integral. This is not convergent one. This is divergent one. This is 1.13 question we have done. Now let me talk about 14th question. The question number 14, which is the last one. Let me talk about that. Where it is? Question number 14 now. I'm sorry. Question number 14th. Okay, now in this case, if I divide this question is 0 to infinity. Now e raised power minus x square dx. Now if I divide this into two parts, let me divide this. This is 0 to 1 if I take. Okay, or yeah, this is 0 to 1 e raised power minus x square into dx, plus this is 1 to infinity. If I take it as x into e raised power minus x square into dx. Now this function is finite here. This is the convergent. Now this function will also be convergent here. So if I take x square equal to something, now let me solve this question. Now this is greater than this value. Here e raised power minus x square or 0 to 1 dx. Okay, is less or this is greater value is less or equal to 1 to infinity x e raised power minus x square into dx. Now if I prove that this is convergent, then this will also be convergent. This is finite integral, so it is convergent for the x square. Okay, so let me solve it here. Now 1 to infinity x into this I have just taken x into e raised power minus x square into dx. Putting x square equal to t, let me take x square equal to, or let me take minus x square equal to t, no problem. This is minus twice x into dx equal to dt, or x dx equal to minus dt upon 2. Here limits infinity at infinity, minus infinity you may say. Okay, so this is infinity, t equal to infinity. Where is 1, then this is minus 1 here. Minus 1 to infinity limits, or no problem limit. Finally we will convert it into the same function. So let me first convert this limits same. Now I'm not changing the limits. Not to change the limits. Finally we will convert this into x, then put the limits then. Okay, so this is 1 to infinity only. Now in this case it is minus 1.2 e raised power t into dt. Now if I integrate this, it will be e raised power t only. Now let me solve here. So this is equal to minus 1.2 e raised power t integration limits 1 to infinity. What it will be? It is minus 1 point. Okay, so this is 1.2 only if I substitute for infinity is 0. E raised power infinity is 0. It is plus sign 1.2 only because e raised power t is e only. Or if I convert this into x square, so it will be x minus x square here. T is minus x square. Then put the limits. Okay, so now I have to put the limits here. I'm sorry. Now it is okay because it is infinity. Minus infinity is 0 here. This is 0 plus 1.2. Negative value, this is minus 1 here. It is 1.e. Now this 1 twice e, this is positive. This is minus 1 here. Because if I put the lower limit, I'm sorry. Yeah, this is plus sign. This is 1 twice e. This is greater than 0. 1 twice e is positive value. 1 twice e if I put the lower limit. But I've converted this into x square only. T equal to x square. We took minus x square. Now put the limits 1 to infinity. If I put the infinite limit, then it is x raised power x in place of x infinity. That means e 0. So e raised power infinity, it is 0. 0 into something 0. But this is 1 twice e. It is positive, hence it is convergent. Now this function is convergent here. Second part. So first is also convergent. Okay, so this is convergent. Hence, the second part is convergent. The first part will also be convergent. Hence, 1 to 0 to 1 e raised power minus x square dx is also convergent. Is also convergent. So this is convergent here. This function is convergent because it's positive value. This is convergent. Both parts are convergent. We can say now, because second part is convergent, first part is also convergent. Hence, 14th question is convergent. This is what you call comparison test of convergence of improper integrals of first kind. Comparison test we discussed about. Mu test also we have discussed about. There are certain other tests we will discuss in the next lecture. Okay, in the next lecture series. In this case, what is improper integrals of first kind and their test of comparison of convergence of when the function is said to be convergent, if the limit of the function within the given limits exists. Okay, if the value is there and the function is bounded, the integrand given is bounded, that means its limits exist. That means function is convergent or it converges to a certain value, certain definite value. That means I, we took the definition part as I. A to infinity fx dx is equal to I, suppose. Where I is some definite value. That means function is convergent. If it is equal to infinity or 0, does not exist within the given limits, then function is said to be divergent. So that we have discussed about. Comparison test and mu test. Mu test, we multiply x raised power mu into the given function fx, suppose into dx. If this value will be will be convergent if mu is greater than 1. If mu is equal to 1, function is not convergent. Mu is greater than 1, then function is convergent, or less than 1, then not convergent. So this is the mu test, and comparison test we have discussed about. Okay, so improper integrals, convergence of improper integrals of first kind that I have discussed today. Second time, this is about next topic. Okay, so that will see you in the next lecture. Okay, we'll see you.